Good day, I'm Dr. T and welcome to my office. So I'd like to set a few terms to give some framework to where we're going to be going in future video series, as well as kind of where we've been a bit. So as chemists, we can think of materials in basically two different categories: pure substances and mixtures. Pure substances are going to be things that are one thing. They are one chemical. I cannot do what's known as a physical change to them and separate those into other things. Physical changes are going to be changing the form of a substance, but not changing the material. I'm not going to be changing fundamentally how the chemistry takes place within that substance. The opposite of physical change, of course, is a chemical change, and in a chemical change, we are changing how the chemistry takes place within the substance, how the atoms are connected to each other, how they're interacted. We are changing ions from ions to atoms, or vice versa, or from one ion to another. We are fundamentally changing the nature of the material in a chemical change. So pure substances, those cannot be affected by physical change. You can change them. You can take, say, pure water and boil it. You've gone from liquid water to gaseous water. That is a physical change, but it is still water. Now, pure substances actually do break into two categories. You have compounds, which can be broken down and changed via chemical change. And so in this case, you have material that is made up of two or more different types of atoms, and you could, via chemical change, separate those atoms apart and turn that compound into its constituent components. The counter to that is the element. An element is only made up of one type of atom. Physical change cannot change its nature, nor can chemical change it and break it into its constituent parts. You can do chemical change to form an element into a compound, but you cannot break down an element into its constituent parts by a chemical change because it is only comprised of one atom. It has no constituent atomic parts. Dropping it into, say, electrons and neutrons is completely out of the range of normal chemistry, and we will leave that to the nuclear physicists. Now, those were the pure substances. Compounds, which are two or more elements put together and can be broken apart by chemical change, and elements, which are one type of atom, and that's all you got. Now, opposed to pure substances are mixtures. Mixtures are going to be two or more pure substances placed together. Now, compounds must be arranged in a fixed ratio. If I have sodium chloride, I have one sodium for every one chlorine. If I have calcium chloride, I have one calcium for every two chlorines. However, in the case of a mixture, there is no fixed ratio. I can have any ratio I would like of my constituent parts. Additionally, I don't need to do a chemical change to separate a mixture apart into its constituent pure substances. So if I have salt water, I can have any ratio of salt and water that I would like up until the point where the salt no longer dissolves in water. Additionally, I can separate them by simply doing a physical change. I can heat the salt water and boil off the water, and thus separating the two. Now, when it comes to mixtures, we actually break those into two general categories, although there is definitely some gray area between them. A homogeneous mixture, homo meaning same, genius meaning substance or mixture, looks like one thing. The classic case would be that aforementioned salt water, at least as long as the salt has dissolved. It looks like one material, you can treat it as one substance, but in reality it is a mixture of substances. As opposed to the homogeneous mixture is the heterogeneous mixture. Hetero, different, genus or genius, mixture or substance. In this case, it clearly looks to be two substances. There are pockets of one substance within the other. The quintessential example is spaghetti and meatballs. You have spaghetti noodles, you have pasta sauce, and you have meatballs. Each one of them are their own discrete clumps. They are a mixture as they are put together, and it would take some effort to separate them. But you can distinguish the parts because they're not uniformly dispersed within each other. Now, with that said, in later videos, I'm going to expand upon these topics. I have dealt mostly with elements so far with discussing individual atoms, And shortly on in the series, I'm going to jump more into the topic of compounds, and then later on deal deeper into the realm of mixtures, essentially building up complexity during the video series. So with that said, have a wonderful day.